How do we show that two functions are inverse functions of one another? Well, let's say f and g are functions, and they are inverse functions if and only if this happens. F of g of x equals x for every x in the domain of g of x, and g of f of x equals x for every x in the domain of f of x. Let's take a look at the example. So we have f of x equals 6 over x minus 4, and g of x equals 6 over x plus 4. And how do we show that these two functions are inverse functions? Well, we first need to show that f of g of x will equal to x, and then g of f of x will equal to x. So let's show that f of g of x is equal to x. So what is our g of x? We need to first find f of 6 over x plus 4. So instead of x for f, now you have to substitute 6 over x plus 4. So you end up getting 6 over x plus 4 minus 4. Remember, this came from substituting this value instead of x. So what happens when you simplify? 4 and negative 4 cancels out. You get 6 over x. Now what is that? This is the same thing as 6 divided by 6 over x, which is the same thing as 6 times the reciprocal of 6 over x, which is x over 6. Notice now that the 6 cancels out, you do get x. So you need to show all this work to prove that f of g of x equals x. So we're done with this part. Now we need to work on g of f of x equals x. So now we need to work on g of f of x, which is 6 over x minus 4. So now instead of x, we need to substitute 6 over x minus 4 instead of that x. So 6 over x minus 4 plus 4. So what is that now? This is 6 divided by 6 over x minus 4, which is the same thing as 6 times x minus 4 over 6. So 6 cancels out here. You end up getting x minus 4 plus 4, which is x. So we also showed that g of f of x is equal to x. Therefore, we can conclude that f of x and g of x are inverse functions of one another. Let's say you have a graph of f of x, and they want you to sketch the graph of f inverse of x. What would you do? Well, it turns out that f of x and f inverse of x, or f inverse, are symmetrical with respect to y equals x, which is this line right here. In other words, if this is a paper, if you fold the paper along y equals x, then these two graphs will overlap one another. And notice, this is a y equals x, and this is a graph of f of x. If there's a point right here, and exactly opposite on the other side of y equals x, this distance are the same distance. There's another point on f inverse of x. And this has to be perpendicular. All these lines has to be perpendicular. So if there's a point on f of x, and across y equals x, there's a point on f inverse of x. So knowing the graph of f of x, you could use y equals x to kind of sketch the graph of f inverse of x. And we'll look at some examples. So here we have y equals f of x. And they want us to use a graph of each function to graph its inverse function. So knowing that we have f of x, they want us to sketch f inverse of x. So let's first draw y equals x. So it will be something like that. And let me use a different color. So remember, f and f inverse of x are symmetric with respect to y equals x. So that means when you fold a paper along y equals x, they have to overlap. So the graph will look something like this. And again, the distance from here to here, which if that's perpendicular, should be the same thing as from here to here, and so forth. And over here, they overlap. Let's take a look at this graph right here. Again, we need to graph y equals x. If you want to graph the inverse of g of x, and it has to be symmetric with respect to the y equals x. So it's going to look something like that. So I hope you get the idea.